The inverter selection, we went with the microinverters, one per panel. They do their maximum power point tracking for each individual panel, so they're less susceptible to you know, if you use a central inverter, and they may have improved the technology, but if you had one panel that gets shaded in an array with a central inverter, the performance drops pretty significantly of the whole array. In this case, you only lose performance on that particular panel. And if that panel fails, that's the only one that goes out. And with the performance monitoring that's included, you'll get an error message, hey, the panel number such and such is not producing. And there's a safety consideration. I've worked in industry, and I don't like to deal with 400 volts DC. You know, I think that's in industry. That's kind of that's sort of a point where you have to do more. And a lot of people would argue with that. Say, yeah, but it's well insulated. And if you go with a central inverter, you may have to deal with that kind of a DC voltage. With the microinverters, they basically have they tie in. It's all daisy chained together, and you produce 240 volts AC, which ties directly into your residential service. So, the racking, the mounting, that was an issue. We had to work it in. This is the recommended design from the vendor. We use Iron Ridge racking, which is one of the older manufacturers. They've been doing this for a long time. The rails are extruded aluminum. They come in 17-foot sections, and it's acting weird. But these are the only two arrangements that they will warranty. If you put the racks, the rails parallel to the long edge of the panel, it's not warranted. They won't support the wind loading and that kind of thing. So we ended up with this kind of arrangement, basically because it's on the side of a building. We didn't mount it on the roof, of course, but this being on the side of the building, you could mount the rails and use the locations for each stud as your mounting points, and then the panels bolt to the rails. The recommended spacing for the and that was another issue, was the loading. When you mount the panels vertically, now the lag bolts that you're using to hold the rails on tend to, they're loaded by the fact that the panels are, they're suspended a couple of inches away from the thing, so you have the possibility of pulling the lag bolts out, which you wouldn't have on a normal roof mount. So we had some discussions, and basically the recommended spacing was 48 inches, and would be three studs, and we reduced it to 32, and that increased the capacity enough to meet their requirements.